properties of limits and direct substitution, hopefully you have seen that sometimes the limit of f of x as x approaches c is simply f of c. In other words, whatever x is heading towards, I just simply plug it in. I've told you in previous videos, that's the first thing I do is I check, can direct substitution work and give me a y value? If so, then that is the trend in y, and that is the limit. In such cases, it is said that the limit can be evaluated by direct substitution. That is, the limit of f of x as x approaches c, I simply pop the c in for the value of x, and I get f of c, and that is the y value, and that is the limit. So we love those functions. Why? Because they're so easy. There are many of these well-behaved functions, such as polynomial functions, which you study in Algebra 1 and 2, rational functions, which you study in Algebra 1 and 2, those have fractions, and any rational function that has a non-zero denominator. We saw when the zero was in the denominator, or rather when the denominator is zero, we have a vertical asymptote there, and so it's just the opposite. The limit does not exist. So some basic limits can be found very easily. Let b and c be real numbers and n be a positive integer. If we have the limit of b as x approaches c is b, well, that makes sense to me. That would mean something like the limit of 5 as x approaches 3 is 5. Why? Because y equals 5 is just a horizontal line. What's the trend in y if y is always 5? It's 5. How about the limit of x as x approaches c? For example, the limit of x as x approaches 4 is, we're simply going to use direct substitution. The trend in y is that y is heading to 4. So we can find that limit quite easily. The limit of x to the n as x approaches c, again, this means direct substitution will work. The limit as x approaches 10 of x to the 3, say, is 10 to the third. I'm using direct substitution. It's a beautiful thing. And as long as n is even and c is greater than 0, the limit of the nth root of x as x approaches c is simply the nth root of c. So this would be like the limit of the fourth root of x as x approaches 16. Well, that would just be the fourth root of 16, which of course is 2. We can find that. What am I doing? I'm doing direct substitution. So in this case, direct substitution. In this case, direct substitution. In this case, direct substitution. Here, I try to do direct substitution, but there's no variable. I'm stonewalled there. So the answer is the trend in y is simply whatever number y is a constant equal to. Included in this list of functions that you can find their limit by using direct substitution is the trig functions. For example, now not all trig functions and not for all input value x, but for example, I can do direct substitution here and get sine of pi. No, you know from your unit circle that the sine of pi is 0. And here, if I do direct substitution, I'll have cosine of 0. Now you know from direct substitution, from your unit circle that the answer there is 1. Simple. The trend in y here is 0 as x squeezes it on pi. The trend in x is also 1. Now, look what that means if we're talking about this graph of cosine, for example. We know that cosine goes max, 0, min, 0, max in both directions. Now, if I squeeze my x closer and closer to 0, where is y trending towards? Well, we could put the whole table out there, but I have this point 0, 1. As x squeezes it on 0, where is y going towards? Well, y is heading towards 1. That's what that means. It's the trend in y. And here, as x heads towards pi, sine is 0 max, 0 min, 0, etc. And that is 2 pi there. So here is pi. There is my point. As I squeeze my x closer and closer to pi, where is the trend in y? Well, y is heading towards 0. It's on this line right there.